Okay, welcome back. So continuing with Tkinter nodes. So let's try the next piece of code here. So I'm on example 6. All right. So let me remind you, we are doing Tkinter. So you need to import from Tkinter, import everything. All right. So what are we doing now? We want to draw in the canvas of the given width, given height, start with a margin, create a rectangle from the margin endpoints until, okay, so you want to leave the width of margin away, fill it with color orange and width 5. This is the outline width. All right. Next, now create another rectangle 10, 20, fill it with green. So we did this in our previous lesson. Build an oval. Now oval, notice you need 2 points. These 2 points are the same points as here. So what is this oval? It is that circular object which will fit precisely in the given rectangle. Okay. Now here is a new command for you, canvas.createLine. So createLine is the method from the canvas object starting from point 150 to point 300 150. Okay, color it red, width is 5. Okay, width of the line is 5. Polygon starting with this point, next to this point, next to this point, next to this point, and because it's a polygon you will come back to your original point. Okay, so let's run this code. All right, so let's see. First the orange rectangle, so it's in the background, then the green rectangle, then we have a pink oval, then we drew a line, and this piece is the polygon, okay, colored yellow. So notice you could have written these within parentheses to reflect that they are points. So this is one point, this is the second point, this is the third point, this is the fourth point, and notice we return back to make it a polygon. All right, so next code, here we are. So we need to import math, okay, and let's try this. This is a beautiful output. What you get here is the face of a clock. Okay, let's run this. What you get is a face of a clock. So what does this say? From the center, you want a circle drawn. And then you want these numbers 1 through 12 written on the inside of the circle. Okay, so we have colored the circle yellow. That's our choice. You could change it to something else. So let's see how it's done. So you're given width, height. Width over 2, height over 2 are the coordinates of the central point. Radius, we have taken minimum of width and height over 3. So that is the radius of the circle. So here you have the center. I want my circle smaller than the square. Okay, so that's why I have taken the radius to be minimum of the width and height over 3. Okay, now how do I create this circle? The circle is an oval object fit within this square. So cx minus radius, cy minus radius. So here is your center. So cx minus radius, cy minus radius will be there. Cx plus radius, cy plus radius will be here. So you have a circle embedded within this particular square. Okay. Now change your radius now to a little smaller. So 85% of the original radius. So this will be the location where you will write your numbers. You don't want your numbers to fit right on the boundary. You want it inside. So we have taken 85%. You could have taken something else. You can play with it. So we have 12 hours on our clock. So for hour in 12, you first measure the angle, pi over 2 minus 2 pi times hour over 12. Okay, so there is a little bit of mathematics involved. Okay, pi over 2 is straight up, that is 90 degrees, right? Minus 2 pi hour over 12. So 2 pi, see, if hour is 0, then this doesn't come through. If hour is 1, you want to be here. So pi over 2 minus, so you want to cut out a little bit from pi over 2, and 2 pi hour over 12. So you see, why is it 2 pi? An entire circle is 2 pi. Okay, so this particular sector has angle 2 pi times 1 over 12, right? So 2 pi over 12. Whereas this particular angle has twice of the previous angle. That's why you need hour there. Okay, each small angle is the entire 2 pi over 12. So that corresponded to 1 o'clock. For 2 o'clock, you needed twice the angle that 1 gave you, right? That's why 2, and so on. So from 90 degrees, you're cutting off something, cutting off something, cutting off something, and so on. And we are allowed negative angles, right? So x is cx plus r cosine theta. Now this you must know, you probably know that x coordinate is cosine of your angle and y coordinate is sine of your angle. This you probably know from your mathematics pre-calculus class. All right, that's all I'm using. But this is the case, these two formulae hold if the center is 0.00. You understand? Now our center is not 0.00, it is Cx, Cy, okay? And radius is the length. So this would be the case if center is 0, and radius is 1. Otherwise, x equals r cosine angle and y equals r sine of angle. Okay, so if radius is not 1, you need to put r in your formula. Now this still holds if the center is 0, 0. What if the center is not 0, 0? Okay, if the center is, say, let me say Cx, Cy, then the x coordinate is Cx plus r cosine angle and y is Cy plus r sine of angle. Okay, so that's why our angle, our x is Cx plus r cosine of the angle, our y is Cy. It should be plus, but instead I have a minus because you realize in TK, in graphics, 0, 0 is here, 500, 500 is here. In other words, upside is down. That's why our y has a minus. Okay, now you are simply creating label, which is a string of hour, if hour is positive, otherwise 12. In other words, if your hour is 0, you don't want 0 o'clock, you write it as 12 o'clock. Now you are creating text, that's how you place numbers there. Okay, hour X, hour Y, those are the coordinates of your point. The text is the label that you get, correct? And that you do it for every hour. This is the font that is used. Let's run this once more with a different color. I don't know, say gray color. And here is a gray clock. All right. When you kill it, it says bye. So bye for now until the next recording.